The Higgs boson was a great discovery. The Higgs boson is a very special particle, very different from the other elementary particles that have been discovered before. Its role is special. It has the role of giving mass to the other elementary particles and so enable the fundamental constituents of atoms to stick together, because if the constituents of atoms, the electrons and the quarks, do not have a mass, atoms will not stick together. So the Higgs boson is a very special particle. Of course, it would have been very, very nice to discover other particles, but the fact that we have not yet discovered them, I'm saying yet because the Large Hadron Collider has only delivered, say, less than 10% of the ultimate amount of data, doesn't mean that this is a negative thing. On the contrary, in physics, in science, in research, first of all, measurements of known particles and of known quantities are of primary importance to make a step forward, but also being able to eliminate possible theories or show the way to move forward. And this is made through discovery, but also through showing that some particles that were expected are actually not there. The Large Hadron Collider at the moment is in shutdown for 2 years. 2019 and 2020. We have this shutdown period regularly to perform maintenance and upgrade of the collider. At the moment, we are upgrading some components of the accelerator chain to be able to start data taking and operation again in 2021 with more intense proton beams, and so to be able to produce more collisions, and therefore to have larger opportunities of measuring known particles and also looking for rare phenomena. At the moment, CERN is studying a future collider, a post-LHC collider. We are in a phase of design studies and R&D of the accelerator components, and we have 2 different projects on the table. One is a linear collider, smashing electrons and positrons of a length between 11 and 50 kilometers, depending on the energy and increasing with time. And the other one is what we call future circular collider, a 100-kilometer ring, so 3 times bigger than the Large Hadron Collider. Both projects that have not yet approved are very important to push our understanding of the Higgs boson. First of all, the Higgs boson is still largely a very mysterious particle and is in some way related to some open questions, outstanding questions in our understanding of fundamental physics, related, for instance, to the fate of our universe. Is our universe stable or metastable? If it's metastable, one day it will collapse. So it's very important to get to know the Higgs boson much, much better than we know it today. But also, with these newer accelerators and colliders, we are going to also address outstanding questions in particle physics. Dark matter is still a question mark. We don't know 25% of the matter of which the universe is made. Understanding where the antimatter disappear. At some point in the history of the universe, matter-antimatter that were before in similar quantities, nature at some point decided to favor matter over antimatter. Thanks goodness, otherwise we will not be here. But still, we don't understand why and how. So these instruments will allow us to make a gigantic first step forward in our understanding of fundamental physics and the universe. They are expensive, but they are not going to be paid in a few weeks. The cost and the payment will be extended over decades. We are talking about decades. There is big international competition for hosting the next big collider after the LHC. Japan is thinking of a linear collider, and China is thinking of a 100-kilometer ring, like the future circular collider. This testifies to the importance of fundamental physics, because if Japan and China are interested in doing this big, in building this big accelerator, it means that the science is interesting and the technology that they will allow develop are interesting. Why do we want to have such a big collider at CERN, so in Europe? That's simply because with CERN, Europe over the past 60 years was able to bring back the leadership in fundamental physics from the US and other places in the world back to Europe. CERN was founded in the aftermath of World War II with the goal, on one end, to bring back scientific excellence and leadership after the war, where many scientists had migrated out of Europe, and then, of course, to foster peaceful collaboration across, through science. Over the past decades, CERN has gained this leadership and has the ownership of the technologies, the cutting-edge technologies that such big colliders requires. And we have the technologies, we have the leadership. It will be a pity to lose it to some other regions of the world.